Welcome to our session where we're looking at regression and correlation. So we are going to look at confidence interval. But the background for those who missed our initial class, we're saying regression is very important because it helps us look at how one variable affects the other second variable. So correlation will measure the strength and direction of the two variables. So we spoke about the fact that we need to understand the dependent and independent variables. So independent variables, X is what causes a variation in the dependent variable, which is Y. So this brings about what we call a causal relationship. X is the input, Y is the output. So correlation between two variables explains how the strength of the relationship may be. So R is given by this formula, which we simplify it as what? S, S, X, Y over square root of S, S, X, X times S, S, Y, Y. So this is a variation in X, and it's a variation in Y, and it's a variation in X, Y. So this is the formula that we were given. Are we together so far, Mr. Wheeler?
Yes,
So
yes.
we talked about the relationships can be positive, strong. The direction of the relationship is given by R. The range is between -1 and +1. So if you have a positive R, it means there's a positive relationship. If you have a negative R, it means there's a negative relationship. So that's the role that R plays in telling us whether it's a positive. So this is a positive, strong relationship. This is R 0.6, meaning it's a positive relationship still. All right. Then we have our R, which is -1, the negative relationship. So these are the relationships that we have. Are we together so far? Any questions? So whenever the relationship is zero, meaning the dots will be unstructured. There'll be no relationship at all, meaning the regression line will be R is equal to 0. Okay? So now that is where we're going to learn how to come up with what? The significance of the correlation. So to identify the significance of the correlation, we use a t-test. So the significance of the correlation is used to determine whether the population uh, coefficient is statistically different from 0 or not. So if our p is equal to 0, it means there's no relationship at all. Okay? If our R is not equal to 0, meaning there's a relationship at all. There is a relationship, which is yes. So the step one in doing this regression is by identifying our null hypothesis. So our null hypothesis is p is equal to 0, p is not equal to 0. But then the hypothesis is to calculate the value of the t. So t is given by r over 1 minus r squared n minus 2. And we have all these parameters if we are given. So if we're given a study like this here, we want to calculate or test this. So hours of study and exam score, which one do you think is a dependent variable? Which one is a result? Okay, so our independent variable is X and our dependent variable is Y. So the question is asking us to find the correlation between hours and exam scores. So how do we find the correlation? You can come up with this change in X, Y, X squared, Y squared, then you find the totals here. Summation of X, summation of Y, summation of X, Y, summation of X. So when you fuse them in, if you can't remember the formulas that we did, X, X, Y, Y, you can use this long formula. We get our R here as what? 0.86 2. So this is our R, 0.862. Okay? So now, we can use this one now to test the hypothesis. So I want you to build on what we learned from there. So the significance of this R can be tested using hypothesis testing. So to test the significance to be given a confidence level, for instance, of 0.05. So you say our null hypothesis P is equal to 0. Our hypothesis P is not equal to 0. So if we accept HO, it means that the regression is not significant. Now, this is also important in your studies as you are doing or conducting a test between two relationships. So when you find that your your null hypothesis has been accepted, it means that there's no relationship at all. So the second step is to calculate the value of T. So T is given by R 1 minus R squared N minus 2. So from here, our N is what? 1, 2, 3, 4, 5, 6. Our N is 6. And our R we calculated as 0.862. So you can fuse it in here. 0.862, 1 minus 0.862 squared over 6 minus 2 as part of the formula where we get your T value as 3.4. So we need now to understand how to compare this T value from our T test. So you need to go to the T score table to identify the critical values. So you go back to your statistics in understanding how this value is. So after calculating the T, we will go into the table, we check under 4 and under 5%. So we're going to find that your value of T is at 2.776. So if the answer that we found, 2.776, 2.776. So here and here. So if the answer we find is inside here, meaning we accept our HO, meaning the regression equation is not significant. If the answer we found is in the shaded region, meaning we reject HO, meaning the regression line is what? Statistically significant. I don't know whether you remember from your statistics how to read the T table. The T table is simply found by the following notation. You find the degree of freedom, which is n minus 2, 6 minus 2, which is 4. Then the alpha level that you've been given is 5%. So you check under 5% and under 4. The reading you're going to find will be 2.776. So this is what you will use to determine. So since our value that we calculated was 3.4, it is greater than the 2.77. So we reject our null hypothesis and conclude that the correlation is not equal to 0. So the relationship is statistically significant. Are we together? So I'm taking you to us understanding how we're going to treat our interval at 95%. So we ended on question part C. So we need to understand how to test the hypothesis at 5%. All right? So what was your error? What did you get as your error? Mr. Wheeler, what did you get as your error?
The error was giving me 0.410423. I didn't round off.
Your error, before you get the error
0.
squared, your error is what? Your error squared?
Oh, okay. So what I did was I just used the same formula for
This one?
R squared.
Okay. What was your error squared?
So it's giving me 0.410423.
0.41.
1, 0.
So when you square root it, you
Yeah.
get your error. What is your error? Square root it.
The error is 0.410.
0.4.
410. That's the error squared.
Then when you square root it, it becomes the error. What is the square root of this?
So that answer is squared.
Yes, already squared. So to reverse it, I want this is the coefficient of determination. What is the coefficient of correlation? So just square root this.
Zero point 168.
0.168.
168.
Correct. So now let's test the hypothesis. What is step one? State the hypothesis. What is our now hypothesis? B2 is equal to 1. Our alternative hypothesis has been given as B2 is not equal to 1.
Is not equal to 1.
Okay, step 2, we need to calculate our T. What is our T? What is the formula for T? I gave you the formula for T. What is the formula for T? Hmm? R,
Which one is a T? Is it the significance level?
the critical value. R square root 1 minus R squared over N minus 2. Okay? So R, over 1 minus R squared over N minus what? 2. So our R is what? 0.168. And our R squared was what? 0.41423.
Oh,
Our N, what was our N? What was our N in here?
it's 200.
Pardon?
200.
200.
200.
400. Minus N minus what? 2.
2.
Mm-hmm. So what do you find as your T? Are you calculating?
Yes.
What's your value? Okay, so whatever value you get, for instance, it is 2.53. So now you're going to compare it with the Z value here. Our Z value here is 1.96. So here we put 1.96, and here we put 1.96. So the T value that we are getting, if it's the rejection region here, we're going to say the regression is significant.
So it's given 3.083.
Answer is 3 point what?
3.083.
Good, this is 3.083. Then the Z we've been given is what? 1.96. So our 3.083 is in the rejection region here. So we can safely say our regression equation is statistically significant. So when you're testing this, by rejecting HO, which says B2 is equal to 1, then here B2 is not equal to 1. So at 5%, we can agree to say the regression equation is statistically significant. So this is how you test the hypothesis. But how do we find the confidence interval here? This one is a little bit not complicated because all the formulas are there. So we calculated what was our B2. What was your B2? You have the formula for B2 is here. What was our B2?
The bit was given 0.815.
0.815. Okay.
15.
So we want to find the confidence interval here. So where there's B2, put 0.815. Then the Z has already been given as what? 95%, 1.96. So we put 1.96 here. Okay. Then the B2 is 0.815 again here. So where there's an issue is now calculating the value of the standard error. Now, standard error, we've been given the formula. Standard error is given by what? What's the formula for the standard error?
Isn't it the same one? Standard error B2 is equal to, I don't know what sign is that, over SXX to the power 1/2.
Is this a comma? It's different from here.
Yes.
So meaning standard error is equal to this answer, okay, over B2. So we need to find what our um, uh, variance is. So to calculate the variance, we'll do 1 over n minus 2, which is 200, minus 2. And what was SYY?
SYY, it was given 60.77.
60.77 minus xy.
XY, it was given 30.5, 30.59.
30.59. And xx,
37.51.
37.51.
0.51.
Okay. So the answer you get is called the variance. Since you have all these figures, the answer you're going to get is what? The variance, which you're going to put where? Here. Over x. X to the power half. The power half means you can it's a square root. So my interest is you finding the standard error, which you're going to put where? In here. Then you're going to find the confidence interval. So confidence interval, for instance, if you have a 5 here plus minus 2, you get the lower limit, 5 minus 2, which is 3, 5 plus 2, which is 7. So I want you to try this one. It's just an issue of substituting in the formula and solving for are we together? So try to do that
Yeah.
and give it to me tomorrow so that you finish it up.
Okay.
Okay, basically tonight we're just about finishing up this part, but it's not complicated, it's just the formulas that you need to know. All right? Then tomorrow we'll look at these other calculations, question 6. For today, I need you to finish up that. I'm happy with the input of the work you've put so far. I think we're going to end here.